Hello all, welcome back. Today we are going to talk about Kerberos authentication protocol in detailed manner. So if you haven't seen my last video, in that I explained Kerberos protocol in a simplified manner. I explained the why it is used and what is the flow between the client and the file server in a very simple manner. So if you want to see that video, I will put that link in the description box below. So in this video, we will deep dive into the Kerberos protocol, the messages which are exchanged between the various components of Kerberos protocol. So let's deep dive into the working of this. So as you know that in this typical scenario of any system, we have a client, maybe like some users or machine or app servers, which want to access and resource on the file server, or maybe any the service in the backend. So those are like first we have to authenticate the client before it can basically access that, right? So in this particular Kerberos protocol, as you know that we have the key distribution center, which is having two servers, authentication server and ticket granting server. And when a client want to access any particular file or any service in the backend, it will send its message to the authentication server. So in that user request, it will be having basically the username, ID, and the file server resource name, and the lifetime for the TGT, like ticket content ticket, which it needs to access for the file server, right? So these things are sent by the client to the authentication server. After the authentication server receives these requests, it will find the username or ID in its database, which is basically a pre-configured value. After finding that particular user ID, its password or secret key, it will verify, okay, this is the particular user which is already configured in the database and want to access particular file, right? So at that time, the authentication server will create a couple of messages. The first one will be having the TGS name, that the ticket granting server name, its ID, then timestamp of the request, the lifetime of the message, and second message, it will create the TGT, the ticket granting ticket, right? That it will be having the values of the username, user ID, TGS server name, its ID, timestamp. Okay, then it will also generate a symmetric session key. Okay, it is called as the TGS session key, and that will be part of both messages. And the first message is encrypted with the client secret key or its password. Second message, that is ticket granting ticket, will be encrypted with the TGS secret key, which is known to the KDC, basically not to the client. Then these messages are sent back to the client. After client receives these messages, because the client secret key or password is known to client, it is able to decrypt the first message. When it decrypts the first message, it has access to the TGS name and the all things like the session key also, right? So these things user is able to find out, but it cannot decrypt the TGT or ticket granting ticket because client doesn't have access to the TGS secret key because it is not shared with the client. Now, client is going to create couple of requests. Basically, in the first request, it will put the file server resource name or service ID, whatever the service or file it want to access from the file server. And the second thing, it will put basically the lifetime of ticket. What is the lifetime of the session it want to establish with the file server? In the authentication message, it will put the username, user ID, and timestamp. So first message, this is the message, is not encrypted, it's a plain text. In the second message, which is the authentication message from user side, it will be encrypted with the TS session key. If you recall, this session key user has received already from the authentication server. Now, these messages will be sent to the ticket granting server. Along with, it will also send the TGT back to the TGS. After these messages received by the uh, TGS server, it will basically process everything. And first thing, it will check the request from user. It will check the file server resource name or service ID, what service ID user want to access, and it will verify in its resources database whether the particular file or service is available or not. Okay, then it will also find the service secret key. I mean, whatever the service is there, right? Is it will have some secret keys before we access. So those things will receive by the verified by the TGS server. Then it will decrypt the ticket counting ticket, and from there it will find out the username, TGS name, timestamp, and the session key, which was already sent by the AS to the client earlier. When it has access to the TGS session key, it can decrypt the authentication message which it got from the user, and then it can find the username and ID that it will verify, okay, whatever the username or ID it has got in the authentication message is same as what is mentioned in the ticket granting ticket message. When everything is fine, it will also verify that whether this user is already has already sent a message already to access this server or not. So it will have one cache setup. In that cache, it will verify, okay, this authentication message is already present or not. If it is present, then good. Otherwise, it will make an entry in the cache. So till now, we have seen that the client has sent a request to TGS, and TGS verified all those stuff.
Now let's have a look at the various messages that are uh, created by the TGS server. Like first message is having the resource ID or the service ID which you can want to access. Then timestamp of request, a lifetime of message. Then second message, which is basically a service ticket. That will be having the resource name, resource ID, and timestamp of request. Then TGS also generates a symmetric session key that it terms as service session key, right? Then first message is encrypted with the TGS session key, and second it encrypts with the service secret key. Once these messages are prepared by TGS, these are sent back to the client. Now, client will process these messages. First message it can decrypt because if you remember, this DA session key was already sent to the client, so it will be able to decrypt first message. From that, it will obtain the service session key, right? But a client cannot decrypt a service ticket because it doesn't have the hold of the service secret key. Now, a client will be creating one message to be sent to the file server, and that will be it will input with the service session key, which it just obtained from the TGS. Then this message, after encrypting it with the service session key, will be sent back to this file server to process it, along with the service ticket which was sent from TGS to client. Then, because the file server already have access of service secret key, it will be able to decrypt first message. From there, it can obtain the service session key. and with this key, it will be able to decrypt the second message. Now it will validate, okay, the username or ID in the service ticket is same as the whatever it is in a user request, and few other checks and balances it will perform. Once it is fine, then it will create a new message to be sent to client, basically a service authenticator message that will be having the resource ID and timestamp. Okay, but before that, it will check in the service cache whether this user is a new user, or there have been some requests already made from this user or client. It will verify in the service cache. If it is a new user, it will make an entry into it. Then these messages are sent back to the client. Now, client will be able to decrypt this message because it already had this service session key, which was passed earlier. And once this is able to validate the message, this completes the flow, like in which the Clever protocol works, and basically authenticates the each other, like client and the file server. So this concludes the whole flow, like the messages exchanged between the client, KDC, and service cache. So, but if you have any questions or some doubts, because these have a lot of encryption keys being exchanged and sent, so please ask me in the comment box, and if any queries there, I can make a further video as well if required to clarify on few things. So for now, thank you for, yeah, one more thing actually. So yeah, before a client start to communicate with client server, it also has a user cache, right? In the user cache, it will basically cache these session keys and all those stuff. So it doesn't need to ask or get these keys from the KDC or the file server in future. So it also maintains a user cache at its end. Okay. Yeah, so thank you very much for watching. See you next time. Please leave any comments or questions, as I said earlier, and I will try to address them best of my capability. Please subscribe my channel if you like the video. Thanks a lot.